Hi there and welcome to the video. In this video we are going to talk through the addition and subtraction of fractions, starting with some easier examples and then by the end of the video looking at some more complex examples. Okay, we have the first example on the screen here. If I want to add 1/6 to 3/4, I've got an initial problem because I can only add or subtract fractions when the denominator, the number on the bottom of the fraction, is the same. So in this question, you can see I'm dealing with a 6 and a 4. Those numbers are not the same. So I need to manipulate the question, alter the question, so that the same number appears on the bottom of each fraction. We do that by finding a common multiple of both 6 and 4, a number which is divisible by 6 and 4. We could use any number that is divisible by 6 and 4, but we usually try to use the smallest number possible just to make things a little bit easier. So if I'm thinking about a number that is divisible by 6 and 4, I would be thinking of 12. 12 is in the 6 times table. It is also in the 4 times table. So I'm just going to change my question to look like this. Let's have a little look at what I've done. For the first fraction, this 6 has become a 12. To get from 6 to 12, I've multiplied by 2. Therefore, I've had to do the same to the numerator to make sure I'm still dealing with an equivalent fraction. That's where my 2 comes from. If I look at the second fraction, to get from 4 to 12, I've multiplied by 3, which is exactly what's happened to the numerator, 3 times 3, giving me 9. Now my question's a lot more straightforward. Now I have that common denominator. All I need to do now is go ahead and add the numerators. So at this point, my denominator remains the same, and I simply add the numerators. 2 add 9, telling me that the result of this addition was 11/12. If at this point I could simplify the fraction, I would do, but in this case I am unable to simplify. Okay, let's have a look at another question. 1/3 plus 3/5. So again, I have a problem. I don't have a common denominator. I'm not dealing with the same number on the bottom of the fraction. Therefore, I'm going to manipulate the question, I'm going to alter the question, I'm going to use 2 equivalent fractions which do have a common denominator. A number that is divisible by 3 and 5 would be 15. I could have used 30, I could have used 45, I could have used 600, but we usually use the lowest number possible just to make our calculation that little bit easier. And it also means we don't need to simplify too much at the end of our question. Okay, so I'm going to make my question look like this. From 3, I've times by 5 to get 15, which is exactly what I've done to the 1 here, times it by 5 to get this numerator of 5. From 5, I've multiplied it by 3 to get the common denominator of 15, which is exactly what I've done to this. 3 times 3 gives me 9. Now I've got my common denominator. I can go ahead and add my numerators. 5 add 9, giving me 14 out of 15. Again, can't be simplified. If I'd used the common denominator of 30, my answer here would have ended up as 28/30, which would have simplified down to the exact same answer, 14/15. Couple more examples from me. We'll go through this one a little bit quicker. 1/2 plus 2/5. I don't have my common denominators, so I think of a common denominator. I could use a number which is divisible by 2 and 5, a number which is in the 2 times table and the 5 times table. I'm going to use 10. You could have used 20, you could have used 100. I'm going to use the lowest number possible for a bit of ease. To get from 2 to 10, I've times by 5, which is exactly what I've done to the numerator here. To get from 5 to 10, I've times by 2, which is exactly what I've done for the numerator here. Then I go ahead and add my numerators together. 5 add 4, giving me 9/10. Last example from me before I give you a task to do. This time we're looking at a subtract, but you'll notice that the method is pretty much identical apart from the step here when we are going to subtract the numerators, not add the numerators. Okay, I've got 5/6 minus 1/3. Question's a little bit different this time because 3 can go into 6. So I could change both fractions to use a common denominator of 12. However, I'm going to leave this 5/6 as it is, and I'm just going to manipulate this fraction and change it to an equivalent fraction with a denominator of 6. So I'm going to change my question to look like this. So the 5/6 has not changed. To get from 3, I've multiplied by 2 to get this denominator of 6, which is exactly what I've done to the numerator here. 1 times 2 is 2. Now I'm left with a question where both my denominators are the same, so I can do the subtract. 5 minus 2 is going to give me 3. 3/6, and in this case, I could simplify my final answer down. Okay, so that's your process for adding and subtracting fractions. Basically, you're aiming for a common denominator and then going ahead and doing the calculation. Okay, here is a task for you to have a go at. Remember, you have the ability to pause the video at this point. If you could pause the video and copy out each question and complete each question with full working out, showing me the common denominator you're using and showing me your final answer. Could you have a go at the 6 questions, please? We've got some red questions, which are slightly easier, amber, a little bit trickier, and then the green questions, just a little bit more complex. Okay, could you pause the video at this point and have a go at the 6 questions? Okay, welcome back. I'll just go ahead and put my solutions up to the 6 questions that you have hopefully just worked through. So my answers look like this. Could you just take some time, again, you can pause the video if needed, to mark and assess your own work. If there's any corrections to do, you could always rewind the video, watch my examples again, and then attempt the questions where you made slight errors. Okay, let's make things a little bit more complicated. So this time we're going to do an addition of fractions, but the fractions are presented as mixed numbers. So we've got 4 3/4, add 2 1/3. So we've got a mixed number, 4 3/4. We call it a mixed number because it consists of a whole number and a fraction. A whole number and a fraction. Hopefully we are familiar with converting between top-heavy fractions and mixed numbers because we're going to use that process in this question. I will talk us through it just in case you need a little bit of a refresh. Okay, so first thing I'm going to do is I'm going to change this question so I'm just dealing with fractions. I don't want the whole number involved. So I'm going to change the question so that each mixed number is presented as a top-heavy fraction, so that each mixed number becomes a top-heavy fraction. So I'm going to change my question to look like this. Let's have a little look how I got that. I did 4 times 4, which is 16. So I had 4 wholes. 4 times 4, which is 16. Added that onto the 3, which is where this 19 came from. So now I'm dealing with a top-heavy fraction. 2 times 3 is 6. Added on to the 1 that's already on the numerator, that's where this 7 comes from. Notice that the denominators do not change when we convert to a top-heavy fraction. So now I've got the exact same question. This and this are the exact same question. They're equivalent questions, just this time it's presented as a top-heavy fraction rather than mixed numbers. Now I'm going to go ahead and answer the question using the same method we used earlier in the video. So I'm going to look for a common denominator between 4 and 3, which is going to take me to the common denominator of 12. To get from 4 to 12, I've multiplied by 3, which is exactly what I've done to the 19. That's where the 57 comes from. From 3 to 12, I've multiplied by 4, which is exactly what I've done to this 7, which is where the 28 comes from. Then I go ahead and add my numerators. 57 add 28. It's going to give me 85 over 12. So I've done my calculation using improper fractions or top-heavy fractions. However, usually when we are given an answer as a top-heavy fraction, we would convert it back into a mixed number to give a more appropriate answer. So I'm just going to change this back into a mixed number. So my final answer being 7 and 1/12. How did I get from here to here? It would be, we look at the denominator, 12. How many 12s go into 85? That would be 7. 7 12s take me up to 84, which means I have a remainder of 1. So that's how I convert back from my top-heavy fraction into my mixed number. How many 12s are in 85? 7, remainder 1. 7 becomes the integer, the full number, the big number at the beginning of the mixed number, and the remainder becomes the numerator. The denominator always remains the same, 7 and 1/12. Okay, one more example from me. So this time we are subtracting mixed numbers. Again, I'm going to convert the question, so I'm dealing with top-heavy fractions. When we're dealing with top-heavy fractions, I just feel it's a little bit easier to work through the method, and it also means you can apply a consistent method to all your addition and subtraction questions. I'm going to manipulate the question so it looks like this. How did I get there? 3 times 3 is 9, added to the 1 that's already there. That's where my 10 comes from. 1 times 5 is 5, added to the 4 that's already there. That's where my 9 comes from. So I've changed my question to look like this. It's the exact same question, just presented in a different way. Now I need my common denominator. I'm going to use 15. To get from 3 to 15, I've times by 5, which is what I've done to my numerator. From 5 to 15, I've multiplied by 3, which is what I've done to the 9. So at this stage, denominator stays the same, and we go ahead and subtract our numerators. 50 minus 27, giving us 23 over 15. This is an answer. However, usually we would present our answer as a mixed number, so I'm going to convert it into a mixed number. How many 15s are in 23? Well, that would be 1, remainder 8. One lot of 15 with 8 left over, and then my denominator remains the same. So the answer to this subtract question, 1 and 8 15ths. Okay, so now it's your time to have a go at some very typical exam questions. You'll notice that in each question, it asks you to show that. So it gives you the calculation, and it already gives you the answer you're aiming for. So your 2 marks, or 3 marks, or 4 marks are all method marks. They're all to do with how you have shown the examiner, or how you have shown your teacher how you got to that solution. So the marks are available for method marks. So in each question, I'd like you to use the method we have discussed in this video, and I'd like you to show me your full written method, how you got from the original question to the answer by showing your working out. You have the ability to pause the video here, and then I will go through my fully worked solutions once you unpause the video. Okay, welcome back. Let's have a little look at my solutions. Okay, so I've shown you my full working out. I've tried to highlight what I've multiplied by to get my common denominator. You can see the common denominator in question 1 is 30 and nothing needs to be simplified. Very similar for question 2. For question 3, however, once we change to our common denominator of 20, you get 31 over 20, which is a top-heavy fraction. Because it's a top-heavy fraction, we always want to give our answer as a mixed number. How many 20s are in 31? 1, remainder 11, as I've noted here, which gives me this mixed number, 1 and 11 over 20. Remember, your working out may look slightly different to mine. You may have used a common denominator of 60. You may have used a common denominator of 40, but your final simplified answer has to be what the question said, so you would have to simplify down to get the same result as me. Again, you have the ability to pause the video at this point if you need a little bit longer to mark your answers. And you can see my working out for the 5th and 6th question. Remember, 4 marks available for each of these questions. So you can see there's 4 different steps along the process of getting your answer. First step being the change to top-heavy fractions. Then we're looking for a common denominator. Then we're subtracting a numerator. And then we're converting from a top-heavy fraction back into the mixed number. Very similar process for question 6. Okay, very well done. If you were able to answer all of those questions correctly, you've shown some very good understanding of adding and subtracting fractions. Okay, and for the final task in the video, I would like you to work through the questions I've put on the screen now. So the questions go from A to L and they increase in difficulty as you work through the questions. As always, you have the ability to pause the video at this point. I would like you to pause the video and have a go at each question, showing your full and accurate working out. Could you pause the video now? Okay, welcome back. Hopefully you've had a go at these questions. Remember, they do increase in difficulty, so you should have found the questions at the beginning quite simple. They already have a common denominator for A and B. For C, a very easy manipulation, multiplying the first fraction or turning it to an equivalent fraction of 2 over 4. So then you have your common denominator. As we get to the end of the task, some much more complex questions. Let's have a little look at my answers. My answers look like this. Could you spend a little bit of time marking and assessing your work? And if you're getting these questions correct, especially those on the bottom 2 lines from G to L, then that is fantastic. You've shown a very good understanding of adding and subtracting fractions.